Good morning, afternoon, or evening, wherever you are, and welcome to today's webinar. My name is Shamir Ozeri, and on behalf of the entire Algorand team, it's wonderful to have you all here. We have a great session ahead of us where Russ Fustino will be teaching us how to build applications on Algorand. Out of respect to your time, we have decided to limit this to 1 hour, so Russ will be covering a lot of ground. Get your notebooks and double screens ready. We're excited to announce the launch of the Algorand Developer Office Hours, which you're all invited to participate in. Office Hours will bring team, partners, and community together for a live discussion intended to provide you with all the answers and resources you need towards building useful, meaningful applications on Algorand. Visit algorand.com/developers to sign up. Lastly, if you're a builder, an individual, or a team looking for ways to fund your project, we want to help. And the Algorand ecosystem offers plenty of resources and funding opportunities that you can tap into, whether it's the Algorand Foundation's $250 million Algo Grants program or the recently announced Asia and Europe Accelerator programs. There's a lot going on. We encourage you to visit algorand.foundation for more details. On that note, and without further ado, I'd like to introduce Russ Fustino from Algorand's Developer Relations team to teach us all how to build blockchain applications on Algorand.
Hello, my name is Russ Fustino, and I'm a developer advocate for Algorand. So are you new to Algorand blockchain development? What are the possible solutions for blockchain? Features for developers. What can I do on layer 1 right natively on the blockchain? And how about the toolbox? As any great technology evolves, you always see lots of community tools and third-party tools that are available to make your jobs easier. We'll take a look at those. And how about just getting started in building solutions? And we're going to cover that too. And finally, if you are brand new to blockchain, we have some other videos as well you want to engage with. Basically, if you are brand new, it's really just a distributed ledger. Everybody has a copy. It's read only and write once. And each block is tied to the prior block in the chain, making it very, very secure through hashing algorithms. If you want to take a look at that video right here, there's a nice section where I go into detail on that right in the beginning. Today's agenda, we're going to talk about blockchain use cases, as well as layer 1 features and developer tools. So let's go ahead and start in on the first section here on blockchain use cases. Crowdfunding is an example of a type of solution that is great for blockchain. So let's see why. Traditionally, it's hard to get funding, and there's an inherent lack of trust among participants. Investors need to trust inventors, and inventors need to trust investors. Also, an audit trail is highly desirable because you want to know where the funds have gone and account for every piece of that funding. So the solution, blockchain makes funding process safe. It offers transparent access globally. It provides a nice, automated, secure approach to crowdfunding. And the terms of agreement are defined in computer code, typically a smart contract, for example. And atomic transfers are important on this. You want everything to complete. You want payment to go from A to B and then B to C, and it doesn't work unless all of that is done. So that would be the atomic piece to that. So this facilitates investors to raise funds in hopes of success, as well as get a return on investment. And it really is a new skyline for many investors, a new way to raise funds for crowdfunding. So blockchain, great solution for that particular application. Supply chain management is another, has a lot of other issues as well. Traditionally, it's very difficult to manage. There's a big information flow, lots of paperwork to sign off on, and a flow for materials as well, typically are part of a supply chain management process. Financial capital might be needed to tie all of these processes together, and coordination among multiple stakeholders is often needed as well. So let's take a look at the solution. Blockchain technology enhances efficiency and transparency, all the way from warehousing to delivery and everywhere in between. Data is more interoperable as a result, and shared data and information is easier to suppliers, manufacturers, vendors, and it is tamper-proof as well. This establishes trust. The gaming industry. Let's take a look at this one. So gamers are typically at the mercy of game developers. Players are bound to the developer's server space. Developers change the rules sometimes in a game, and developers hold the power to change or remove items. So once again, this is all developer focused, not the focus of the gamer. Players are basically merely licenses. So in the gaming industry, a solution might be something like Gods Unchained, right? This flips the script. The gamers actually own the assets, or crypto tokens. We'll talk a little bit more about crypto tokens in a minute. So player is in control, has the ownership, has the management, does the maintenance, and is globally available. Then we get to content and entertainment distribution. So the issues are many here. Traditional challenges with content distribution is it's not a decentralized approach. So there might be several different vats of information regarding copyrights or regarding patents. And it's difficult to determine many times which artists are affected, as well as other copyright holders as part of the process too. So lack sales transparency, also an audit trail. And it is about copyright piracy. So these are all issues, right, that we have today around content distribution, as well as censorship perhaps. The content entertainment distribution solution with blockchain eliminates the piracy via content copyright tracking. So we're starting to see a common theme here amongst these solutions. A read-only, write-once database that's very, very secure seems to emanate in a lot of these type of solutions. All transactions are recorded in a ledger and offers personalized content experience, as well as provides opportunities for seamless payment transactions on a global basis. And this is also very, very important. You're not bound to the boundaries of a particular country to do transactions. This can be done anywhere on this planet. So some other use cases that are I want to mention here, at least, are in the way of charity organizations. For example, the China Ministry is using blockchain to improve transparency of social services and tracking of donations and audit trail. This happened after misuse of funds back in one of the earthquakes many years ago. And that is really what's needed. And then also voting. You got a tamper-proof way of voting. Once your vote is on the chain, it's voted. That's it. There's no double voting, just like there's no double spending, right, with the protocol that's in the Algorand blockchain. Automotive, another big area, supply chain visibility, vehicle integrity, all parts of that. This particular report that I'm referencing here is the China blockchain report on this particular slide. And that is where they have started to introduce sensors in the vehicles and engines that automatically report maintenance. And this goes on the blockchain. So now the details of the wear and tear of spare parts and sensors are writing to the blockchain, and there is no question as to what this car has been through. DeFi apps are exploding in 2020. 20 billion of crypto dollars and stable coins are floating around. Many Algorand DeFi examples you see listed there, including stable coins like Tether, USDC, and MELD, as well as Flex FinTech. Some good DeFi examples there listed. We have more use cases up at Algorand, algorand.com/use cases. And we have a growing Algorand ecosystem as well. Many technical companies represented here. We'll be talking about a few of these here today, and then we have GoalSeeker and AlgoDesk and Algo Signer, as well as financial infrastructure across exchanges and wallets and stable coins. And there's a big ecosystem of applications that's building on a daily basis. Year one by Algorand by the numbers. We went mainnet a year ago, June, and we also have we're on track for over 10 million users on the blockchain by the end of the year. All right, so let's take a look at a demo here on crypto tokens. We had talked about this earlier, and we're going to actually create one visually here with Algo.io. We're also going to take a look at a couple blockchain explorers that we have, as well as a globally accessible tool. We talked about this being globally accessible, and that would be AlgoSigner. So it's like a wallet right into the browser of Chrome. And really what we're going to be showing you here is how to create an Algorand standard asset or asset management. So we have a great tool here, this Algo.io. Also there's an application manager as well that they have. We'll show you the asset manager here. So this will be your account that gets created. You want to copy that key off, so if you ever have to restore it, you can do that. And let's go ahead and log in here. First thing we're going to do is create an asset, and all visual. Let's call it Russ coin. Let's go with 10,000, decimal point of 1. And then you have the URL. So if you want to hook this up to, for example, IPFS, you can use that URL field. The metadata hash will use the default, as well as these different roles that you see here. We have a manager address, a role that manages the overall asset. You also have the ability to assign different accounts to be able to freeze or unfreeze the asset. There's one that's in charge of the reserve, and there's another one that can do clawback. So we're going to set those all to this HGB account, and let's go ahead and create it. Let's go ahead and see what got created. Right down over here is the new account. And if you go out to Goal Seeker, what you can see here is the information that was done with the assets. So pretty cool stuff right there. And then also you have the ability to send this asset to other accounts. You can also modify the asset to change things like the manager address or any of the addresses that are associated with the management functions of freeze, reserve, and clawback. If you own all of the assets, you will be able to delete the asset. And the SDKs provide programmatic access to every one of these features as well in all of the SDK languages. So let's go ahead and take a look at AlgoSigner next. It is a Chrome plugin that you can install. I'm going to go ahead and bring up my information here for my account, and I'm going to go ahead and send Algos. And let's go out to this particular address, put my note. So let's go with 3 Algos that we're going to send, and let's go ahead and create this transaction. And there it is. So there's our transaction ID. Let's go ahead and copy that off, and let's take a look at one of these other browsers. We have Algo Explorer. There's actually, I think, a third one now available. It's up on our community page too. And so same deal. Let's go over to testnet and go ahead and paste this in. You can see you could paste in an address, a transaction ID, group text ID, a block number, an asset name, or an asset ID to do your search on. So here is the 3 algos that we just sent from my account to the receiver, which is going to be this NI2 address. So you can actually see the exact timestamp that this was actually issued as well. So very discoverable, very open, very easy to access transparently, these transactions. In the next section here, we're going to look at layer 1 features right on the blockchain. So these are features the developers are loving and getting very excited about. The first one here is called Algorand Standard Assets, or ASA. That's actually what I created when I went to the AlgoDesk demo and built a coin. And also we have atomic transactions. And we have Algorand smart contracts as well. And there's a new feature called rekeying. So let's talk about all these and what they are. So first and foremost, let's talk briefly about the blockchain pure proof of stake protocol. It has true scalability, able to scale to billions of users. Infrastructure longevity is in place as the entire project is open sourced, as well as our verifiable random function, which is used in the pure proof of stake protocol. Technical flexibility as well. We've done many upgrades already, and very smooth and really not noticeable by the user whatsoever. So no downtime on that. Transaction certainty is very, very important. Instant transaction finality. We see this happening as a real world requirement. You know, if you think about it, if you're doing point of sale action and it takes you 10 minutes for a block to create, like on some other blockchains, it really is not conducive for point of sale transactions. You need something that is confirmed instantaneously, and that's what happens here with the transaction. Platform extensibility. Many SDKs will be showing you that we have available to build solutions for developers. Extremely energy efficient. You can run a node on a Raspberry Pi, and the whole process is very green. Cost efficient as well. Transactions are well under a penny per transaction, and providing true security in a scalable fashion of a read-only write-once blockchain with hatching algorithms that tie together each block, and really is tamper-proof. So the ASA are creating Algorand standard assets. You saw a screenshot there on the right of the creating the asset that we looked at a few minutes ago. This facilitates creating your own native token. You can call it anything you want. It has many administrator functions, ability to manage and the whole entire process, or freeze or have a reserve address, as well as clawback functions perhaps that might be needed in some scenarios. Also, you need to opt in to an asset in order to receive it or send it. So this facilitates asset spam protection. All right, let's take a look at some of these example assets. We have fungible tokens first and foremost. This facilitates things like in-game points. We talked about that in one of the gaming scenarios, as well as stable coins, which is tied to, USD, for example, or fiat. And then you have loyalty points, system credits, cryptocurrencies, perfect for this. The next group would be restricted fungible tokens. This would include things like securities and government-issued fiat. And then we have non-fungible tokens. So these would be in-game items, for example, really great for supply chain and real estate. Once again, something that's non-fungible is not exactly the same in each instance, right? So you may have a 4-bedroom house for sale on one street, but its neighbor or one across street might have a few additional features on it. So those are all unique, and you just create a quantity of one, and now you've got yourself a non-fungible token. Identity, as well as certifications and collectibles, are great use cases for this. And then we get to the final kind of set of applications that you can build with assets, and that is restricted non-fungible token. Things like real estate would be good for this, ownership registries, as well as regulatory certifications. And once again, you may need clawback or revoke capabilities on both of those restricted scenarios. So taking a look at this diagram here on the right, we're going to talk about atomic transfers next. So you have person A going to send 50 algos to person B, and in exchange, person B will send a concert ticket to person A. And so this must all succeed or they will all fail, is the bottom line. Very analogous to a SQL transaction for those that are familiar with SQL Server database type calls. It's an on-chain native function and easy and secure to wrap the entire atomic transfer into one transaction. You can support up to 16 pieces to this. So you can go from A to B, B to C, B to D, and then D to A, for example, would be 4 transactions. And then guarantees exchange of goods. The important point about this is you can combine this with other Algorand technologies. So let's say you have a smart contract in the mix and you want that to be part of the transaction, that this smart contract has to be invoked successfully. That could be one piece of this atomic transaction. So examples of atomic transfers might be simplified or expedited settlements. You have things like efficient matched funding, reduced counterparty risk as a result of this. It enables any multilateral trade, circular trades as well, group payments, and you can combine Algorand ASA and smart contracts together. And really, instant state settlement for complex multi-party asset transactions, as well as it facilitates distributed payments. Then we get to Algorand smart contracts. The language is called Transaction Execution Approval language, and the contract logic in short is called TEAL, which is the acronym for that. We have a Python-enabled compiler as well called PyTeal that will be written in Python and generate the TEAL from that. There are two types of smart contracts I want to introduce here. One is stateless and the other one is stateful. So stateless can be used to approve spending transactions. And stateful provides both global storage on the blockchain itself as well as local storage on a per-user basis. And it's very important to point out, this is combinable with other Algorand technologies, including atomic transfers, Algorand assets, and you can combine stateless and stateful contracts. I've repeated that a few times now, how these are all combinable. And it's a very important point to understand because it really is the key to architecting your solution, knowing that this is available to you to be able to combine and mix and match a lot of these technologies together. All right, so what are some of the values of smart contracts? Well, in the financial industry, you have things like trade finance. You have clearing and settlement applications that could take advantage of this. Financial data recording. Audit trails are built right to the blockchain. Digital identity, another great solution for the finance industry. And then in getting into DeFi, you got things like escrows and payments and credit and lending and stable coins. So this really rounds out, a lot of the value of smart contracts in a lot of these key different areas. So let's take a look at Algorand accounts. Right now, you have a standard account. You also have something called a multi-sig account, or multi-signature is what they stand for. And so finally, a third type of account is a logic account or a smart contract. So let's explain these a little bit. These actually refer to signing capabilities. If you have an individual account and you want to send out money somewhere or assets somewhere, you have both a public, which is an inbound key that everybody can see, and a private key that you only use when you want to send funds or assets. So it's a pair of keys there. On a multiple signature account, you have several individual accounts that could be listed, each having its own public and private key, but also the multi-sig account itself has a public key, and you can load funds into that, for example. But the idea here is this: let's say you have three accounts listed in the multi-signature, and you can set up a threshold for maybe two of those accounts. If any two sign off, then the transaction is legit, and you'll be able to send funds from that multi-sig account. So that's how that one works. And then the logic account always returns true or false. And so if it returns true, that's good. And you can go ahead and sign a particular transaction based on that particular contract. So that's called the logic sig. That brings us to rekeying, another great new feature on the Algorand blockchain. You can see it there highlighted in yellow on the left in the Algorand wallet. But what this facilitates basically is, the public versus private key scenario where to date these have been tied strongly together. And if you wanted to swap out the private key, it would be very difficult to do that without creating a brand new public key. So this is a cryptographic key pair, and you can see that on the left here, bound to one account. And what we facilitate with rekeying is separating the private and public keys, which assigns other authorized addresses to approve the transaction. So you can see that in the second diagram. Now the keys are split. And what you can do now is replace that with an authorized signing address, which could be a multi-signature account and it could be a logic sig. So no other blockchain offers a way to change private spending keys so easily, and it's facilitated, you can see up on the right here, by an additional field now that says authorized address for this particular account is this NFF account. All right, let's talk about some solutions here. One is voting. And so let's say you've got a voting commission and you get a spending token. Well, what you want to do is atomically group what I'm about to show you here. So you're going to get that particular token, and then you want to say, okay, I'm going to send it out to an individual to vote. And they want to vote for, say, candidate A. And so now you've got a voting smart contract. And what that will facilitate then is, okay, is this filled out correctly? Is there a candidate, that has been selected and so forth? And if so, you're going to increment the candidate vote total in the way of global state, which you now have available to you in a stateful smart contract to do that. So that's a good scenario right there, pulled together. Another one here might be a typical one, crowdfunding. We talked about this up front as a scenario where you have a crowdfunding escrow account, which is a stateless smart contract with payment from escrow to that particular user. So once again, we're going to atomically group this, and we could say, okay, this is only going to succeed if user one claims the escrow funds, and then you have the crowdfunding smart contract, which is a stateful smart contract that would then go ahead and write out and update the data up on the blockchain. All right, let's get into the cool part of the session, Algorand developers. All right, let's take a look at our portal, and you can see we got documentation, tutorial, solution, articles, and forums. And great documentation on getting going, and this is the one I want to point out first, workspace setup, connect to a node, and then do your first transaction. We'll take a look at that code in a second. Each language has code that's associated, so you can see code samples for Java, Go, Python, JavaScript. Also, we have a command line tool called Goal and another command line tool called Algo key. So we have examples for all of those here. And typically, what we'll see is at the end or at the start of the article, you'll see an example folder, which is a GitHub, and V2 is our latest version. And then you can see for that particular feature of getting started building, you have Go, Java, JavaScript, Python code that you can just bring up and clone out and start going. So a great resource there in the way of tools and getting started, and lots of great tutorials out here. Things like using VS Code with Python or C#, or we got some great articles as well. Great smart contract debugging. We'll be showing you that in a little bit. And really excellent forums. So feel free to use this to post questions, and they're monitored quite a bit. So you can create and run your own node on a Mac, Ubuntu, or other Linux distributions. Example, Raspberry Pi. This used to take several hours, but now we got a new feature also called Fast Catch-up. So you can pretty much get all caught up in a matter of minutes rather than a matter of days if you do create your own node. PureStake and RandLabs provide API services of nodes that are indexed and archived. You can access from the SDK code on platforms that even do not have nodes. And then finally, we get to the sandbox, which is the quickest and easiest way to get going from a developer standpoint. It's a Docker instance. It's not for production. Snapshots start from the current node. There's no sync time. You could access BetaNet, testnet, and mainnet for this, but keep in mind, as soon as you do a clean or reset, everything goes away. So it's made to be a volatile environment, but just one that's really, really fast. These are the 4 SDKs that are supported, Go, Java, JavaScript, and Python. This allows you to build applications for Algorand, and you can see the types of things that you can do here. You can create transactions, you can create accounts, a lot of standalone functions. You can sign transactions, multi-sig transactions as well. There is also a community C# SDK. And there are a few other language SDKs that are available up on our community page. Install and instantiate, very, very easy. So there's a page there at the top, a great reference for updating or installing your SDK. You can see right there, the example on the right is for JavaScript. You do an npm install with Algo SDK. and then you can verify the installed version. And then we have the dispensers that we talked about, BetaNet dispenser and TestNet dispenser. So that's available for developer use. And let's go ahead and creating an account and dispensing funds. And this is the Java example I'm going to show you here first, but it'll be very similar in content and what you would do to create accounts in other languages. So I have a breakpoint set on the third address that I'm creating here. And we should see it go ahead and stop there. You can see we started printing out the addresses down below. I'm just going to run this to completion. And then you can see here you've got your passphrase and your account. Many times you need 3 accounts to do testing with. That's why I like to just use, there's some common code that's out there available to generate 3 accounts. This is what you would want to basically copy off all 3 of these for later use. The one thing you would need to do is go out to the dispenser. It's going to go ahead and paste in that particular account, and now you have algo gone to that account. In fact, again, if you want to go ahead and check this out, I love how you can instantly verify things on the blockchain, and there it is. So 100 algos were sent to the receiver account that begins with DKA there. So that's your first step. The next step then is let's go ahead and do a transaction. So this is a little bit more involved. First of all, you want to specify your address, port, and token like we pointed out in the, I'm using the sandbox right here, values. This line will instantiate your client. And then we have a common routine to call to wait for the confirmation to occur once a transaction occurs. I'm just going to run this, and we're right on the transaction parameter. So what we've done here is we've restored an account based on that passphrase, and he's the one who's going to be signing it. So this is the account that gets restored, and we're going to go ahead and get that address to get the address value, and then we print it out as a string right down over here in the output window. You can see the balance for this particular account that I've used before is listed right below it. And now we're ready to go ahead and send algos to this receiver that you see highlighted on the screen. So things that get built into the payment transaction is the sender address, who's sending it. If you want to have a note field you want to specify, in this case we got hello world sent to that. That's a freeform text field you can use for any purpose in any data structure. Here is the amount we're going to be sending, which is going to be 1/10 of an algo. And then also here is the receiver that's going to get the funds. And then we just go ahead and do the build at the end of that. So I'm just going to go ahead and run this. And then what we'll see here is down below. What happens here is the process is this. You do the transaction, and then you got to sign it by who? By the account 1, who's ever sending it has to sign it. So that would be the account that we restored up at the top. And then the last step, and this is where typically you would see errors if there are any, is do a raw transaction. This statement will broadcast it to the network. So really 3 steps there, right? Do the transaction, sign it, and then go ahead and broadcast it to the network. And you can see now we have the transaction information that is displayed down below, as well as the decoded note that we had entered on that particular string. And let's talk about transactions. We're going to talk about multi-sig and atomic transactions. Okay, so the first example we're going to show here is a multi-sig transaction. This one is done in Python. Many of the tutorials might have code like this to paste in your phrase for your account for ease of testing. Here I've got 3 accounts I'm going to restore here, 2 of which are going to be used to sign, and the third of which is we're going to send it to. And so what I'm going to do now is just fire this up, and we'll stop on my breakpoint where we create the actual multi-sig account. So a multi-sig account is created by providing a version, which is arbitrary, your version of that particular multi-sig account, the threshold, which is how many have to sign onto it, and then your list of accounts that you want in the multi-signature. Now in this case, we have a threshold of 2. We only have 2 accounts, so all the accounts need to sign off in this scenario. If we had a third account here, comma, account 3, we could put in here, any 2 out of the 3 could sign it. And if I step over this now, what you'll see is we have a multi-sig address that can be used, and I'm going to print that out right here. And typically what you would need to do is make sure that this particular account is funded. So again, you'd want to go out to the dispenser to go ahead and do that. And I'm just going to hit run here. We're going to go down to the payment transaction, which you've already seen before in Java. But now you can see there's the sender it's coming from, which is going to be what? That is the multi-sig address. And then you have any parms that are provided in the way of flat fees or block ranges for the transaction. This would be the recipient, which is going to be our account 3, our recipient that we specify right there. And the amount we're going to send is 10,000 microalgos. And then there's a note field that we have as well that we can specify there. I'm going to hit run. And now we're going to go ahead and create that multi-sig transaction object. And that is the transaction part of it. And now we're going to sign off on both of these from account 1 and account 2. This is the pedal to the metal, and I'm going to hit run. And now what we should see is that that particular transaction is broadcast. And you can see the wait for transaction and then the success message down below that it was sent out. So that is a good example of multi-sig. One more example we want to do then is atomic transfers. So for the Go developers out there, now you can see how this is done in Go. All right, so the first thing we got are 3 accounts we're going to be using in this example. I've got balances that are displayed for all 3 of these accounts. And then what we want to do is get the suggested parms for the transaction. We'll go ahead and do that, but then here's where it really gets interesting. So what we want to do here is make a transaction. We want to send an amount from account 1 to account 3. And then we also want to do a second transaction from account 2 to account 1, but we don't want either one of those to happen unless they both do. And that's where we get into the atomic transfer piece to this. So let's do our first 2 transactions. So we have the transaction 1 has been done with the make payment going from the 7 Dog Charlie account to the UAC account. So that's account 1 to account 3. And then we got an amount we're sending for twice that amount. We did 1 algo up here. We're going to do 2 algos right down over here. And then what we can see here is we're going to combine these now into a group. And here's where the magic happens. So we have a group ID that we've computed from these different transaction types that we did, transactions, the 2 above. And then this group ID now is assigned to this group property, so we know that they are together. And then we want to split the transaction group by signing each one independently, right? So now we're going to go ahead and sign this first transaction. And then we're going to sign the second transaction. And now we have both of those done, and what we're going to do is assemble the group transaction for both. So we're going to append these byte arrays to the transaction group, and then there it is, send the raw transaction for both of those atomic transfers. So this is an extremely valuable piece to the puzzle when you're building solutions. And this is something that I think you can see the different balances are displayed at the end of this program down here in the output. So let's continue into smart contracts now. So Algorand stateless smart contracts basically replaces the signing of transactions that would normally be done by either an individual account or a multi-sig account. The logic account is any transaction sent from this account will be verified by the predefined logic. So typical use cases for this might be an escrow style account or split payments or a hash time lock contract. And then you have the logic signature, which is any transaction signed with a signature will be verified by the predefined logic. In other words, there's a delegated authority that needs to sign off on this. This is very useful for reoccurring payments. And both of these use stateless smart contracts. Okay, so let's take a look at contract account and account delegation. So the first thing we're going to take a look at is the contract account. So let me go ahead and fire this up. This example here is done in Python. The code is very simple. You've got an argument. You're going to read it in, and we're going to compare it to integer 1, 2, 3 and see if it matches. If the argument matches, the program is going to return true, and then you can go ahead and sign off on a transaction. So the very first thing we have here is setting up the arguments. Let's go ahead and do that, and then I'm going to create the lsig, which is the logic sig function for that particular program using the arguments. And the program we again specified up here as a result of doing the compile. So there is the source code that is being read in. We've got the compile function, and then we got the program is going to be generated as part of that. Then the payment then will occur, and it will go ahead and sign that particular transaction with the lsig. And this is where the rubber meets the road. And it's going to go ahead and do that transaction based on the contract account. And there it's waiting for the confirmation right now to occur, and it did occur at the very end. So this was a successful transaction. Now the other one, which was the account delegation, is exactly the same, except there's one additional thing that's different. And what's different is the fact that we now have an account that needs to sign off on this as well. So this is going to take this account's secret key and be able to sign off on that particular address as part of this logic flow. And so there is the lsig that was created like we did before, but now we're going to also sign with that particular account. So it just provides that one additional piece of logic. So it's not just whether it returns true or false. It actually is also, in addition to returning true and executing, it needs to be signed by an account. And that's really the only difference between those two. So I'm just going to let this run here, waiting for the confirmation down below, and it will do that. Right there it is. So it is confirmed. Okay, so now let's talk about stateful smart contracts. The first thing we'll talk about here is the life cycle. First thing you would do is to create the application, and then you would need to opt in to participate. All right, and this will provide the ability to use local storage. The no op is basically calling the app to execute it, and perhaps you might want to update the application as well. Other functions include deleting. Accounts use this transaction to close out their participation in a contract. This call can fail based on the TL logic, preventing the account from removing the contract from its balance record. Now, clear state will always clear, and it's similar to closeout, but the transaction will always clear a contract from the account balance record, whether the program succeeds or fails. And this is a great link to take a look at the life cycle, as well as some additional information. Everything is explained here. You come down a little bit further, there are also examples in both teal and PyTeal for how to write state and reading and some of the basic functions. Okay, so let's talk about PyTeal. So the PyTeal you're seeing here will go ahead and generate this teal code that you see here on the right. It uses the compile teal command as well as specifying the mode. So this is an example of setting up a teal program that does, the equivalent like we saw in the last part of the demo, a stateless contract with mode signature. So in other words, you're just going to be signing off on it. So what's going on here basically is the PyTeal will go ahead and generate the teal when you use that compile teal method, and then that source gets compiled into a format which can be used for a parameter in the application create transaction. And let's talk about debugging. We're going to tie all this together in the next demo. Let's take the accounts, the signed transaction, as well as the approval program source. And those all feed into create a dry run request. The dry run request is then used with the teal debugger that you would pass in as an argument for executing the debugger. You can actually see the format of that particular dry run request down below, starting to specify the accounts, and the transaction information will also be in there as well. Once you get to the debugger, this is what it looks like. You'll have step-by-step execution and be able to set breakpoints, all that kind of good stuff. You may need to configure your port number on that as well. But that's about it. You're good to go and using the Chrome Inspect debugger here. So let's go ahead and take a look at all this. We're going to look at debugging stateful smart contracts. PyTeal, we're going to start out with. We're going to compile it using the compile teal to create the source, and then the source we're going to compile to feed into the debugging session. Okay, so what I'm going to do, I've got the breakpoints already set up. I'll just describe this as we go through each particular section. The first piece we need to do is specify the local and global variables that we're going to need in this application. So you have two types of variables. One is an integer, the other is bytes. And in this example, we're going to be just using one int for local and one int for global. Then we've got the two accounts I'm going to recover here. One is going to be used as a creator account that'll create the application. And the user account will go ahead and use this application. What we see here is the first approval program. Very simple program. All we're going to do is increment a global counter. And then the next program, we're going to update it with this program here, which does one additional thing, is it's going to also increment a local counter. And there's also a clear state program that we'll need when we go to create the application. So here we have the compile teal method that we're going to take on that program we just looked at, and it's going to go ahead and generate teal. And I'm going to do that for the updated version and also the clear program. Next we want to do is call this compile program method that I have here, passing in that particular source. This is what it looks like. This is where we're going to be using the client compile method. And what we're going to end returning are the decode bytes. And here's the main line that we have. And this kind of reflects the lifecycle that we had talked about earlier. We're going to go ahead and create an app. Got methods for all of these. We'll drill into them. We're going to opt into an account, both for the user key and the creator. So the creator can also have local storage on their account. Then we're going to call the app and execute it. We're going to first call hello world, and then we're going to go ahead and read the global state so we can see that counter that got incremented. And then we're going to go update the app. We're going to update the app with that refactored compiled program that we have. And then we're going to go ahead and call the app again with this hello world updated teal. So now what this does, it will go ahead and increment local storage. And we're going to go ahead and print out the local storage so you can see the increment there. And then we'll go ahead and close out the application. So this removes the application from the balance record. However, you still can opt back into it. And that'll be the next step we do. We'll opt back into it. Then we'll go ahead and call the app with the updated teal. And then you can see the increments as well once again. Now, the final two steps will be to delete the app. So this is going to delete the application. It clears the global storage only that's associated with the application. The user must clear local storage, and that is done in the final step with the clear app. All right, so let's go ahead and go right through this. That's the lay of the land. So the first transaction we're going to run is this create application transaction. Everything's typical, right? You're going to go ahead and sign it. You're going to send it, wait for the confirmation. And then the result of this is we're going to get an application ID. So we can see that print out down below once we get the confirmation in the output window. All right, and there it is. So now you can see the application created. Next, we're going to go ahead and opt in with the user. So this will go ahead and opt in with the application opt-in transaction. And then what we saw there was we now were opted in. And then we got the second opt-in we're going to do for the creator account as well. And we're back in the main line. I did want to point out a couple things here. When we created the account, we're going to be using the creator's private key. And then for the application to opt in, we've got two of them, one with the user, then one with the creator. And then when we call the application, we're going to call it with the user, as well as when we do the update, then what we're going to see is we need to use the creator private key to update it. Then we've got more calls with the user key till we get down to the very end here on the delete app call. This is going to require the creator key. So continuing on, we're going to execute now, and we're going to run the hello world teal. And we're going to call it. And this is done with the no-op transaction. And what we're going to do is set up our dry run source. So this call gets invoked. You need the field name to be approved. And then we're going to feed in the two accounts right there as part of this. So it's going to return the dry run request. Then we're going to print this out to a file. And let's go ahead and take a look at that. And there you can see all the information that's in that particular file. All right, continuing on, we're going to go ahead and invoke the debugger. So I have an execute command here in the code that's going to take that dry run request as well as the source code file, and we're going to go ahead and start the debugger. So the configuration you might need here is to configure your local host to port 9392, and here we have the teal that was generated. So the very first step you can do is go ahead and create the counter, and we'll go ahead and expand these areas over here. We have both a global counter, and these are the two accounts that we are working with. Okay, I've expanded a few of the areas here on the right to see the different variables as well as the stack. So let's go ahead and step through this. We'll go ahead and step over. We got the counter is now specified in the global space, and we're going to go ahead and increment that counter. We're currently is at 3, and then we're going to add 1 to it to go ahead and bring it up to 4, which is now on the stack down here. I'm going to pop that stack and put it back onto the counter, so now you can see it listed right up here, and that is the the addition of hello world here for doing our counter. So now let's return back to the app. And now that we've got our debugging done, we go ahead and send it out, and we're going to print the global state here at the end of this transaction. There is no local state, so you won't see anything come up for that just yet. And we'll go ahead and take a look at what we have down in our session down below that we just printed off the global state, and there it is. So you see the value that came back in as 4. This value was derived from the transaction record. This routine I'm about to call here, the read global state, this will go ahead and get the account information using the client account info call for that particular address. And so now this is going to display the same information that you just saw up above from the transaction, but now it actually resides on the account record. So now we get to the good stuff here. Let's go ahead and update the application using the refactored program that we created with the local storage in it. And we're going to use the application update method. And at the end, we'll in the transaction response, we'll go ahead and say we updated it successfully. So now we're going to call the app for the user, and we're going to do the update as well. So up above, just to be clear, we did call it with the user there as well, but there was no local storage. The only thing we were updating there was the global counter. Now we're going to update the global counter as well as the local storage. So when I go ahead and run this in the call app, there is the same routine we were in. We're going to go ahead and call the dry run once again. Once that file is created, then we're going to go out to the debugger. And now you can see the additional code that was generated for the local counter down below. Same type of thing. We'll take a look at our global objects here and the local objects as well. So let's go ahead and pop over this. We'll go ahead and increment this by 1 like we did before. So now we're up to 6 on the counter. And then we're going to go ahead and now create a local counter on the stack. And so the local counter now will go ahead and get that value after we retrieve it here. So that's going to have a value of 1. And let's go ahead and take a look at putting that. And so when we put that to the local storage, we can now see it listed over here. And there's the local counter for that particular user account, which begins with AG. So this is pretty cool stuff. And then the last step here, of course, is to do the get, and that's going to put it back onto the stack so you can see it over here with the true value returning. All right, so that was successfully run. Now we're going to go ahead and take that signed transaction. Now if I go ahead and run the both the global and local state, you can see these get displayed down below, and you now also have local state that was published. All right, so now let's close out the app, and that's using the close out transaction. So that was closed out from this particular app. Now keep in mind, once it's closed out, you could still opt in again. And so to prove it, I'm going to show you we're going to opt back into that app so that we can then call it again. Great. So now that finished up, let's go ahead and call it with the updated app. All right, so let's take a look at what we got here. There's our global counter now. There is our local counter. So I'm going to go ahead and walk through this once again. And let's go ahead then and increment that counter. And what we should see happen here is it'll go ahead and update that counter to 2 when we go back, bring that to the app. So the transaction record now is going to have that information in it, and we're going to go ahead and print it off here again. And there you can see now the new incremental value to 2. The last 2 steps, we're going to delete the app. So once again, that will clear only the global storage. And once again, this has got to be done on the creator account. So I use the application delete transaction. So now that app ID has been deleted. However, the clear application must be called from the user account to clear the local storage on the user account. And that's done with the clear state call. And that's it. And the crowd goes wild. How about that? We have a great solution here. We followed the entire life cycle with this stateful teal application. So that brings us to Indexer. Indexer is a great way to query the blockchain. It is extremely quick, which is what you want for any query process. It's accessible through any of the SDKs. There's also a REST API for it too. And it's basically what it does is it scans the blockchain and takes that LLD process and will communicate with it, but then store information into the Postgres SQL database. And so that's really what you're performing the query on. So it's already indexed, it's already fast, and it's ready. It's like a regular database, which is what you want when you're doing queries. So how do you do this indexer thing? How do you do it? Well, you can build your own, and we got instructions on how to build that. I built my own. I've got it running. That will take approximately 3 days to build, but with all the scanning it does. Also, there are services that are available by PureStake and Rand Labs where you can access their index server. So that would be a good thing to do. So let's go ahead and take a look at this demo. For this demo, we are going to actually use our 4th language here today in this video, JavaScript, and it's very simple. We're going to go ahead and get the account info off of that indexer. I have my indexer, this case is pointing to the PureStake IO. Let's run this, and what we'll see is we're going to query an account here that we have specified with the NI2. I'm going to go ahead and just run this lookup account, and then let's go over to the debug console, and we should see the account information that was logged here earlier. And there it is, the account information for the account. And then there is the account with the NI2. So that is all. Those are all the assets, all the information associated with that particular account. The last one I'll show you here is the search by time. And here you can actually put a timestamp in to query a particular transaction. So this is great even for like audit trails. You want to find out, all right, I knew the time of the transaction. Let's dig it up and find it. So there's the start time, and then there's the information about that particular transaction that occurred at that exact time. All right, so some other resources that are available, the developer newsletter. I encourage you to sign up for that. Great, it's a great read, comes through on a weekly basis. You'll see what's new in the developer world. We have some great community projects as well. There's a few other SDKs that are out there. Rust SDK, there's Algoduino, Algonaut. So lots of great community work being done. You can see we've got some IDEs actually available now, and you got some API wrappers and a lot more. Also, I want to make you aware of the Foundation Rewards Program. Algorand Foundation is a separate business entity. I work for Algorand Inc., and the foundation is the token economics company. And we have a developer rewards program. You can, submit a project, get some algos for that, as well as the Algorand Developer Ambassador Rewards. You can become an ambassador by writing, content, maybe some tutorials or solutions for the Dev Portal, for example. There are grant programs that are, larger funded amounts for projects, good solutions and projects. Also, the Ambassador Rewards Program is available too. Speaking of the Algorand ambassadors, you can become one of these. We now have over 500 Algorand ambassadors. These are like our most valuable professionals, or MVPs. You can contact Stephen at Algorand.Foundation for more information. The resources, today's PowerPoint, you can see the bit.ly address at the bottom. You also have forums and Discord, and these are a couple good videos to watch, one on Teal and one on Proof of Stake. And then also, this is where the code is. Where's the beef, right? So here's the code. Under the developer site, there's a GitHub repository for docs, Algorand docs, and then on the GitHub repository for Algorand DevRel, there's a hackathon repository. Wow. So in summary, covered a lot of ground here in this particular video. Covered blockchain use cases with a lot of the issues that are revolved around those particular solutions, as well as what blockchain can do for you on those use cases of crowdfunding and gaming and voting and many more. Layer 1 features, we really drilled into quite a few of those with ASA and atomic transfers and smart contracts. Those are all really key, and being able to tie those all together into solutions is extremely powerful. The developer tools are great. In closing, I want to thank you for watching this video. You can sign up at developer.algorand.org and visit our community page as well. Once again, this is Russ Fustino signing off. Thank you very much.
Thank you, Russ, and thank you everyone for attending today's webinar. We hope you found it informative and that this is just the beginning, because there are plenty of good things yet to come on Algorand and very good reasons to join the ecosystem. We want to help and do everything we can to make it easy and provide you the resources you need to start building. Once again, we invite you to join our upcoming office hours, and we invite you to join our Discord or forum, which are great places to both connect with the Algorand community and team, as well as raise any further questions that you might have. On behalf of the Algorand team, thank you again for joining us. Have a great rest of your day. Take care.